Guys, big review here before we get going. All right, big review because there's a lot we got on our plate today. Quiz Friday, remember, Quiz Friday, Quiz 3 will be there. On Friday, I'll be here today and tomorrow after school if you want to stop by. All right, two chords are intersecting, and they intersect at E. What do you know? I don't want anything about floater angles either. Okay, two chords intersect, and I start putting lengths on here, all four of these pieces. Give me what's equal. Use the segment lengths for me. Use the segment lengths. Why do I have a feeling I'm going to get a lot of not here's today, but I don't care.
Oh, wow, really?
It's the highest number over there because I don't have to go to 30, that's for sure. What's the highest number in that group? Who's the highest number here today? Anybody have higher than 24? Okay, so 23.
Oh, okay, yeah.
26. There we go. Here we go. 3. Got it. Look at that. Good. Give me something. AD. AE times EB is the same as the product of what? DE times EC. We're all good there. Okay? This can also be applied to this diagram right here. Because remember, a diameter is also a chord. So I can still apply what Jake just gave me here. So I want somebody to apply it to this diagram. You have a diameter. It's not perpendicular, so it doesn't bisect. All right? Don't worry about that. Just give me what pieces are equal now. Here you go, 20. DE times EC is the same as, okay, good. What I noticed on Monday when we went over this is you guys like to go from the center to here to say that's the part. No, it's where they intersect. All right, so AE times the other part, EB. Don't go from the center when you give me the segment here. Everyone all right on that? That was Monday. Let me go to the homework for Monday because I want to stay in order here. Page 39 and 40 you had. In your packet, page 39 and 40. Is there anything you wanted to go over right now before we put this to rest? 39 to 40. Some of these will be on the quiz on Friday. Not much, though. Anything going? Pages 39 and 40, did you have any difficulty with anything we need to go over? You're all good? Okay, can I at least see that now? I just want to keep everything in order from day to day here. Yesterday now moved away from chords and went to secants and tangents. So here's an example. What are these up here? Secants, okay? We'll review for Friday's quiz, but hopefully you can find angle C if you needed to. You subtract the two arcs and divide by 2, but I'm not concerned about that. What did we have yesterday on the video as far as the lengths? I gave you guys a little saying, whole times external equals whole times external. And external meaning the outside part. So if you're going to use my diagram right now, give me the segments I can plug in right now. Give me the segments I can plug in. Let's go, 22. I am on, look, no issues today. Let's go, whole secant. Go ahead, AC times BC. Yep. And I don't know if I mentioned this on the video or not yesterday. I think I did. Don't get this confused with the chords. I see a lot of kids do this and just go CD times DE equals CB times BA. It's not part times part. It's whole thing times the external part. All right? All good? And now what did I give you on this diagram? Secant and a tangent. It's still whole times external. Still whole times external. So give me the segments here. 13. What do you have for me? Yep, whole secant times what's the external part? BC. And now when you do a tangent, what do you notice about the whole and external? Same. So DC times DC, or if you're feeling crazy, you can go DC squared. Okay. Now look, last example was two secants. This was a secant and a tangent. Anybody know why I didn't cover two tangents yesterday? You don't need to do whole times external. There's a theorem that says what? Two tangents drawn on the same point are congruent. Okay, so that's why I don't use whole times external on two tangents. Everyone okay there? All right, I picked two examples from your homework last night to see how you did and what you did. First one's number 16, so let's take a look at that. And then I'll answer any questions that you had, maybe if I don't go over them. All right, what are those right up there? Tangent NA, secant. All right, so somebody give me whole times external equals whole times external for number 16. And then I'll talk about the algebra behind it. 19? Yeah, look. What do you got for my whole times external? Okay, everyone good. There's the whole secant. What about its external part? X. And then what about the tangent? All right, so there's the setup. That's the geometry. Unfortunately, now your algebra's got to take over. So you end up with 4x squared plus 5x equals, what happens when you multiply a radical by itself? Becomes the number underneath, which in this case is $1.74. We've got to move the 174 over 4x squared plus 5x minus 174. And this is why I gave you that last problem yesterday in your notes. This is factorable. I don't know if anybody tried to factor it. I have not reviewed this year how to factor something that it's got an a value bigger than 1. It just, I don't know if you remember that, how to do that. I don't know what you do last year in algebra. Did you have a maybe guess and check? I forget what other, I haven't taught algebra 1 in a while, so I know it's guess and check where you just put the two parentheses and start plugging in numbers and see if it works out. What was the other one? Well, that's what I would recommend. That's what I've been recommending all year, quadratic formula. But also, it's like multiply the a and the c value. A and c, 4 times 174. Then I kind of forget. Oh, grouping. Where you take this 5x, make it into two other terms, group them, take a GCF out of each, and okay, well, that's why I'm not reviewing it, because you'll do it again in Algebra 2 next year. What I would definitely suggest, if you didn't know how to factor this straight up, is use quadratic formula. Okay, so x equals, what's your b value here? 5, so it would be -5 plus or minus what I've been suggesting all year here, so you don't get this number underneath the radical incorrect. Store a, b, and c in your calculator, and then do b squared minus 4ac all over 2 times, what's my a value? 4, so 2 times 4 is 8. And then how do I get my two answers from this? I do -5 plus that radical divided by 8, and I do -5 minus that radical divided by 8. And then one of them probably would have been negative, the other would have been positive, so accept the positive one. Okay, certainly something I'm not gonna tell you it might be. I'm gonna ask you to factor on Friday. Okay, you're gonna set a whole times external up. You're gonna have to factor. It will be factorable. Whether you want to use quadratic formula or not is up to you. We're okay on that one? And then the other one also was a kind of a little crazy there. Was 17, 2 secants. So at least somebody just give me a whole times external here. 10. First one. 3. Whole times external, stud. Let's go. Okay, that takes care of this secant right here. Yep, equals. Yep, that's the whole secant times its external part, 8. And then you guys get 3x squared equals 8x plus 96. Move everything over. Again, I like to keep whatever's squared positive. And then this was not factorable, so you did have to use quadratic formula on that one. Okay. Questions, comments, any concerns? Factoring coming up on Friday. Was there anything else from there? I just picked those two because they used quadratic formula, but anything else from the other problems last night? Whole times external? Because we're going in a little different direction today. No more circle rules or anything. We're done. We're done with all the rules. Done. Nothing else? Quiet group here today. Beautiful. Let's see your work from last night.
Wait, no, let's do this first.
Yeah, let's do this first. Let's get through this. If I got to do an interview, I'll do it. And plus, that's kind of cheap. It's half the classes here. How do I know about the other half? It's kind of like me just voting right now without everybody here.
Well, everyone that's not here, like, out.
There's a lot. There's a lot. All right, let's get this going here. How to write the equation of a circle. It looks pretty intimidating, the equation, if you see that there, x minus k plus or x minus h, y minus k, r squared. It's not intimidating, though. All right, it is not at all. I just want to go back to maybe 6th, 7th grade. When you guys graph these, y equals 2x minus 6, and you graphed it, what'd you call that graph? It's a line, right? It was called a line. And then I think last year you guys started graphing these.
Yeah, that was
Parabola, good. And I don't know, did you get into these last year with these exponential graphs? Okay. So a line and a parabola, exponential, they all have a certain equation, and so does a circle. And that's what I'm going to want to look at with you today is the equation of a circle, right? Let me just go back real quick. Anytime you wrote these equations, either for a line, a parabola, or the exponential, look at y and x or just y and x. You never plugged in for those when you wrote the equation, correct? Well, look at the circle equation. Everyone see y and x is in there? You're not going to plug in for that, okay? When you write the final circle equation, x will be x and y will be y, okay? No, it's fine. Thank you. Appreciate it. Okay, good. What you will plug in for is h and k. Okay, and you can see there that will be the center of the circle. All right, so h and k are going to be numbers, and those numbers represent the x and y coordinate of the center of the circle. That's the center. There's another value we haven't talked about, and that is r, and that'll be the radius length. Now, be careful here. You're just not going to plug in the radius length. You have to do what with it before I actually plug it into the equation? Square it. So if the radius is 2, you're not going to see a 2 here. You're going to see a 4. All right, so that's the radius length. And I got another, actually, good news coming up here once we do our first one. Okay, so everyone, all right, h and k I'll plug in as the center, and r will be the radius length. All right, very basic one coming up. Write the equation. I got a center at 3, -3, and a radius of 6. All right, just let me rewrite the circle equation up on my paper here. Okay, h and k are the center. We know the center is 3, -3. So let's start. It's going to be x. What's the x coordinate of the center? 3, so that's my h value. So into the formula, I'm going to just write x minus 3 squared plus, what's the y coordinate of the center? -3. Now be careful. What's going to happen when I plug in a -3 in for k? It's going to become y plus 3. So yes, you just change the signs when you plug it back in. Now be careful. I do not want to write 6 here. I do not want to write 6. The equation says it's the radius squared. So what number will be showing there? 36. Now, hey, I have had kids do this. Fine, I'm not going to argue with that because it is correct, but come on, you're better than that. 36. And there's your first circle equation. I said there was good news. You don't have to double distribute here. That's it. Leave it. Leave it. Leave it. I don't have to do x minus 3, double distribute. Nope, we're done. That's it. Leave it just like that. Beautiful. All good. All right, I gave you a graph now. What's the equation of this graph circle? Well, I need to find the center first. The center's not 3, 3. That's on the circle. Sorry. It should be 1, 3. Yep. And it shows you the radius length is 2. So now I'll start calling on you guys here, maybe. How about 15? 25. 1. 7. Oh, I thought you said not here. And I'm like, okay. Go ahead, Allie, you're up. So here we go. X. Yep. 1 all squared. Yeah. Keep going for me. Plus. All squared. You're good there. And then I'm going to ask somebody for the right side now. Number on the right side. What did I have up here before? 17? 4. Thank you. 2 squared. This isn't too bad yet, right? Not too bad at all. Okay. Let's see if I can stump you. No, this is not honors yet. Sorry. You have seen nothing yet. Trust me. You have seen nothing yet. This is cake. This is cake. Okay, the center is 0, -2. Ooh, radius. Going to see if I can freak anybody out if the radius length is the square root of 26. Okay, here we go. Left side first. I got a 5 in the house. 16 in the house. I don't care. 5. I don't care. 23. Okay, ready? Left side only, Kate. Left side only. Ready? X. What's the x coordinate of the center? So -0 squared. I'll get back to that in a second, though. Plus, what's going to be in the y one? Y plus 2 squared. Got it? Ooh, here we go. Radius length is the square root of 26, but I got to put it in squared here. So what is going to go into the right side? 16. Don't care. 6. 26, because again, what happens when you square a radical? There you go, Teddy, the number underneath. Now, I will warn you, if this is multiple choice, you're not going to see that as an answer. They're going to clean up that left side over there. X -0, and then you're going to see this instead. So if we see this written out, that tells me the x coordinate of the center must be 0. Because they're not going to leave that x -0 in there. They have a little self-respect. Okay? Everyone all good? Going? You still haven't even seen the worst of it. Here we go. Now I don't give you the radius length now. I need your help finding it. I do give you the center though, right? -3, -2. So let's set up the left side of the equation first. Set up the left side. You're up, 18. Yeah. Like it, I like it. Like it a lot, and then all of a sudden, we don't have the radius to square. But I do know what? What's that what's that 1, -2 stand for? That's a point on the circle that goes through. It's a point on the circle that goes through. We don't have a radius, Teddy, but that's what we're trying to find. But what? But what? Talk to me here. But what? Correct. From the center, -3, -2 to 1, -2, that would be my radius. If I could find that length, I could do distance formula. Okay, all right, yes, I get it. This is what happens when I deal with honors. You realize right away that you can count this. But I'm going to tell you most often than not, you're not going to, what if I can't count it? I can use distance formula or, remember what we talked about at the beginning. What are x and y here? Those are points on the circle. So you could take 1, plug it in for x. You could take -2, plug it in for y, and then what are you going to get out? r squared, which I need. All right, so you can either use distance or plug in. That's what I'm going to do right now is plug in x and y. And then I got a mind-blown moment coming up. So here you go. 1 plus 3 squared plus y plus 2 squared. Sorry, we're going to plug in for y. We're going to plug in negative 2. So negative 2 plus 2 squared. All right, go ahead. Figure out what that's equal to on the left side. What's that r squared value going to be? Oh, boy. I get 4 here. 4 squared. 16. I get 0 here. 0. So it's just r squared is. Now, look, if you want to take the step and say r equals 4, that's fine. But what do you still have to do before you plug it back in? You still have to square it. So you already have the r squared value. That's 16. So here's my equation. Okay, honors kids. What was the other way of finding the radius you told me other than just plugging in a point on the circle? You told me to use what formula? Are you ready? How would you get r by itself? Here. If it's being squared, what do I do on both sides? Hey guys, this look familiar at all? The square root of this? What's this? It's the distance formula. Okay, that's where the circle formula comes from, is the distance formula. Okay, it's the circle formula. All right, that's basically it right there. All right, I know, great. I'm sure you're amazed. Yeah, it was that mind blown moment. Sorry, Teddy. I got a more depressing moment coming up here and a couple problems for you, though. All right. All right, how do I graph it? With a compass. But where do I find points now? So everyone take a look at my equation. I got x minus 2 squared plus y plus 1 squared equals 36. There's 2 things you need. I need the center and I need a radius length, which will help me find a point on the circle. So first here, help me find the center. Now be careful because you guys are going backwards. You're used to plugging it into the equation, but now you're going to take it out. So what were my h and k values here if I have x minus 2 and y plus 1 up here? Dig deep. 12. The opposite signs. Perfect. 2 and negative 1. So everyone can go to their graph right now. 2, negative 1. We plot the center. And now we need to find at least one more point on the circle. What's my radius length here now? Be careful. You're going backwards. 7, 6. Take the square root of 36. Okay, I'm going to turn this over to you guys. How do I find another point then if I know the radius is 6? Count, what do you mean count 6? I can need direction here because I could count 6 a lot. Left, I could go to the right. Up, down. It's up to you. So I'll go 6 up. 1, 2, 3, 4, 5, 6. And then, yes, everyone's figuring out. You take your compass. Make sure the compass point goes on the center. Pencil goes on the point on the circle. And do what you guys probably have wanted to do all year long. Make a full circle around. Look at that beaut. This doesn't want to move. All right. All good. All right, I'll let you take a breather because it's gonna be bad times here. Whew. I even need to take a break before we get into this. You guys doing all right? Okay, I'm good to see you. Missing Ella here today, huh? The group's not complete. All right, here we go, guys. And this isn't, by the way, this isn't honors. All right, I'm not going to ask the question what class we're in here because this is on the Regents too. All right. What don't you like about it? Let's talk right away. What don't you like about it? You're correct. It's not in our circle radius. It's not in our center radius form. I don't care. You better, let's get it into that form then. Okay, let's get it into that form. All right, so I'm going to hold your hand for this one. How do I get this right here? And if you're wondering, this is called the standard form of a circle. All right, what we've been working with is the center radius form. So how am I going to transform the standard form into the center radius form? All right, ready? It is an algebra concept from last year. It is okay if you totally forget that you even did it. Completing the square. We are going to complete the square to do this. Okay? Complete the square twice because you have x's and you have y's up there. First thing, here we go. Make sure the single number's over on the right-hand side. Done. -8's over there. If it's not, you better move it before we start. Next thing, group the x's and the y's together. Rewrite this equation so you group the x's and the y's together, please. And leave that -8 on the other side. So I am going to have x squared. I have -8x plus y squared plus 2y equals -8. So group them together. All right, here's how we complete the square. First, we're going to complete the square on the x's, then we're going to do it on the y's. Oh, anybody want to show off the first step to completing the square? That's got an a and a b value. Everyone agree? What's the b value? -8. You take half of it and square it. You take half your b value, so everyone in your head right now, take half of -8 and then square that number. You get 16. X squared minus 8x. What was your number you got? Taking half the b value and squaring it? Plus 16. Good. Now we're going to do it with the y's. Plus y squared plus 2y. Everyone ready? What's the b value in here now? 2. The b value is 2. In your head right now, take half of it and square it. 2 divided by 2, then square that number. What do you have? 1. So plus 1. And hold off writing -8. Because, hey, I don't know if you've noticed this yet. Please don't let me do this for a while because I'm just going to be embarrassing myself. Here's what basically just happened. Here's where we were on line 1, just like this. And then in line 2, we went like this. I'll wait. You only have 5 more seconds before you tell me what's got to happen here. Thank you. We got to get balanced because what did you just add to the left side? 16 and 1. So you got to add that to the right side to keep this sucker balanced. So I'm going to add 17 to the right side. Here's where the fun begins now. Factoring time. 2 numbers that multiply to 16 but add to -8. But we can write that even cleaner. X minus 4. X minus 4. Oh, no, you see that? What do we got? It's looking like it's looking like we need it. This is where it's coming from, looking like we need it. Get it now. Next one. Y squared plus 2y plus 1. 2 numbers that multiply to 1 but add to 2. Y plus 1, y plus 1, clean it up. Y plus 1 squared. And then look, -8 plus 17. Oh, look familiar? There's that center radius form I love. All right, let's graph it. What's the center? 4, -1. Oh boy. Oh boy. What's the radius length? 3. How about a shortcut before I show you the next one? Because I can guarantee I'm going to lose a lot of people going from this step right here to this one, or maybe in between here to that one. Because you guys try to factor it, and that always isn't the best case when you try to factor. There is a quick shortcut. Notice what number I ended up with, -4. Where did we see that -4 before up here? It was half the b-value. We had a +1 here. Where did we see that +1 before? It was half my b-value. So if you don't want to factor, it's just simply half the b-value inside the parenthesis. Okay? I added 17. -8 plus 17 is 9, right? And where did I get the 17 from? It's what I added to whatever I added to the left side. All right, we got another one because I know one doesn't make us great here. Okay, here we go. Another one in standard form. Before we do it, half the b-value, what do you got to do? Get them to x's and y's and get the 40 over the other side. So x squared plus 8x plus y squared, was it minus 14y equals -40. All right, here we go. What's your b-value for the x's? 8, take half of it. Square it. Okay, so x squared plus 8x plus 16. Let's do it for the y's. What's half your b-value for the y's? Okay, -7, square that sucker, plus 49. It is unbalanced right now. -40, you have to add what to it? What did I add to the left side? 16 and 49, yep. So what's that, 65? 65? Yeah, yep. Don't forget to add it to the right. Don't forget to add it to the right. You should never be left with a negative number on the right side. Because how can you have a negative radius length? It's silly. All right, here you go. X squared plus 8x plus 16 factors into. And remember the trick, just take, what was our b-value before? 8, cut it in half, what'd you have? Okay, so this is going to be x plus 4 all squared. And then what was your b-value over here for the y's? Negative, cut it in half. So y minus 7 squared. And then hopefully this will be a nice number for us on the right side. And it is indeed, what is it? 25. Don't panic. Yes, this is probably will go off your graph. It's okay. Go ahead and graph. What's the center? Actually, let me ask somebody here. I'm going to call in a couple more people. 4. Center, Emma? Darn right. And how about my radius length here? 16. 22. Radius length. 5. Graph it up. Yes, because 2 of them you need to graph, and graph is not optional. You have graph paper at the end of your packet, I believe. Just double check for me. I think we provided graph paper at the end of the packet just for this day. Okay, so that's where I believe it's 24 and 25 can go. Sinead, what's your deal? Yep. You have to show x plus 4 times x plus 4? No, absolutely not. Nope. I do need to see what you're adding, and then the final circle equation, though. Yes. And yes, I am going to ask you to complete the square on Friday. On Friday's quiz, it will not be in your usual. You're going to have to convert it for me.